Okay, graphing from factored form. They're going to give you a polynomial that has already been factored. What you need to do is set each one of the factors equal to 0 to solve it. So we get x minus 3 equals 0, x plus 1 equals 0, and x plus 3 equals 0. And then you solve those. So you end up with x equals 3, x equals negative 1, x equals negative 3. Now these are solutions to our polynomial. But more so than that, these are x-intercepts. So we plot our 3 different x-intercepts. So we have an x-intercept at negative 3. We have an x-intercept at negative 1. And we have an x-intercept at positive 3. Now, from here, here's what you need to do. You're going to create a t-table. I want you to plug in or write down every value from 1 unit to the left of our x-intercept to 1 unit of the right of our x-intercept. So we have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. A rather large t-table, okay? But I started 1 unit to the left. I finished 1 unit to the right. Okay, so that's how you know how far to go. 1 unit left, 1 unit to the right. Now, take out your calculator. What you're going to do is you're going to hit y equals and make sure that there's nothing in there. So now we have y equals. Type in your function, parentheses, x minus 3, x plus 1, and x plus 3. Uh-oh. There we go. Now, once we have our function in, I want you to hit second table. All right, and now it's giving you your table of values. So all you have to do is match your table up with that table that's already on there. So negative 4 is at negative 21. Negative 3 is at 0. Negative 2 is at positive 5. Negative 1 is at 0. 0 is at negative 9. 1 is at negative 16. 2 is at negative 15. 3 is at 0. 4 is at 35. All right? So we have all of our values. Now that once we have all our values, all we have to do is graph it. What you should see, our solutions were 3, negative 1, and negative 3. Well, when you look at this, at 3, negative 1, and negative 3, you should notice that they're all 0. That tells us there they are x-intercepts. So, now here's what I need you to look at. I need you to look at the values in the middle. So everything in the middle. Do not look at the 2 outside points. Don't look at the negative 21 or the 35. Look at the stuff in the middle. My lowest point is a negative 16. So we're going to count by 5s. 5 there. 5 there's. Okay? So negative 4, negative 21. Negative 4, negative 21 is right there. Negative 3, 0. Negative 2, positive 5. Negative 1 is at 0. 0. Negative 9. 1. Negative 16. 2 is at negative 15. And 3 is at 0. 4 is at 35. Now that doesn't fit on your graph. It's okay though, because the outside 2 points, all we need to know is what direction things are traveling in. So 435, that tells me this thing is going up. And that's all I really care about. All right, now we're just going to play a game of connect the dots. There you go. Now look at our graph. It is a 1, 2, 3 degree polynomial. Count the number of x's. 1, 2, 3. The end behavior is down, up. Well, positive lead, positive, positive. 3 positives make a positive. So the end behavior should be down, up. All right? So that's how we sketch a graph. I'm going to give you another example now. So it's going to look a little bit different. let's not do that. Let's do x minus 2. All right, so there's our values. Now, you see something different's happening right here. The entire thing is being squared. Well, what do you think is going to happen right there? I want you to go ahead and think about what do you think is going to happen to our graph at that point, and then we'll discover it together. Take each thing, set it equal to 0. So x equals 0. X plus 2 squared equals 0. And then x minus 2 equals 0. Solve each one of them. This one's x equals 2. That one's already solved. And then solving this one, well, you take the square root of both sides, but what's the square root of 0? It's just 0. So now we have x plus 2 equals 0. Solve it, you get x equals negative 2. Now remember, again, something's going to happen right here. Let's just see what ends up happening on our graph. Plot your x-intercepts. So 0, negative 2, and positive 2. Remember, we need to go one value outside of that. So start to create our t-table. Do a value to the left, and do every value until you get to the right. So that point is negative 2, so one value to the left is going to be negative 3. And then we just kind of keep on counting until we get to one value to the right, which is positive 3. All right, so that's what my t-table is going to look like. If you don't have all that down, hit pause or go back and rewatch it and see what I did right through there. Go to our calculator at this point, y equals, clear out the old function that was in there, and let's type in our new one. So I have x times x plus 2, and then your squared button, keep hitting that. Okay, so let's try this again. X, parentheses, x plus 2. Now I have to hit squared. My squared button is right there. And then I also have x minus 2. All right, so now you can see how the thing's typed in. If you want to look at the graph, that's a sketch of what our graph should end up looking like. And then there's my table. I actually want to see a table of values. You can't just sketch it from the picture. So, negative 3 is at positive 15. Negative 2 is at 0. Negative 1 is at 3. 0 is at 0. 1 is at negative 9. 2 is at 0. And then 3 is at 75. All right. Now again, we're only concerned with the values in the middle. Looking at the values in the middle, I go high as 3 and as low as negative 9. You can count by 1s if you would like. I'm going to count by 2s. So 2. Negative 2. All right. Negative 3, 15. Again, I don't need to plot that exact point. I just need to know that that's telling me that this point's going to go up. All right, so negative 2 is at 0. Negative 1 is at positive 3, so that's going to be right around in there somewhere. 0 is at 0. 1 is at negative 9, so 2, 4, 6, 8, somewhere right around in there. 2 is back up at 0. 3 is at 75. That's definitely not a point I can plot, so I just know it's going to be going up. All right, now connect the dots. Here, back around. Now, let's see what happened. I told you something different's going to happen with this whole negative 2. So let's see how that one's different. Well, at negative 2, you know it's bouncing off the axis. At the other 2 points, it's not bouncing off. It's actually just crossing through. Negative 2 is a multiplicity. Here's how you can tell it's a multiplicity. The entire factor is being squared. So since the entire factor is being squared, that pretty much tells you that this is going to be a multiplicity, and therefore it should bounce off the x-axis. All right, count the number of x's. 1, there's 2 x's here, so 2, 3, and then 4. So that means we should have 4 directions. 1, 2, 3, 4. And it's positive, so it should be pointing up. All right, that is an idea of how to make a graph from factored form. You do not need to do the entire worksheet that's in the packet. Just do enough problems that you know what's going on, and then go ahead and do your test review.